The break. Uh, so right now we are having the board boundary. We have placed the different components properly. Now it's all about drawing the traces. So the traces are actually either in the top layer or bottom layer of the PCB. So actually on the top layer we have the components. So we are placing these ICs on the top layer. So what the bottom layer is just the opposite layer what you are seeing here. So on the top layer we have components. So the traces can be there. Usually if it's a single layer PCB, the traces are on the bottom layer. If it's a two layer PCB, we have both bottom layer and top layer traces. So this is the top layer, this is the bottom layer. Bottom copper, front copper, it's called. So actually in the motherboards or such complicated boards, you have more than two layers. Actually, in a usual motherboard, it's 6 or 8 layer board, but you will not see the inner layers. Inner layers are actually there embedded inside the board. Okay, so anyway, so here suppose we have a single layer PCB, so we have to choose the bottom copper as the layer, and then take this tool is actually the root tracks. So zoom in. So here we have a connection. These white lines are the connections. So we have to draw a PCB trace through the connection. Click here. So the connection is over now. So that connection is over, and see this is green line. Green line indicates that this is a copper trace in the bottom layer, and from this point actually the connection is towards this. And it's always advised in PCB designs to have not to have 90-degree connections, but usually if this is a 90-degree connection, the connection will go like this, but the tool will automatically try to make it as a 45-degree connection. That is, say in this case we will draw the connection like this and complete like this. So the trace is like this. So if it's a 90-degree connection, it's not usually advised to have 90-degree connections because of some signal reflection problems. Okay, so now uh, let's. So this point is getting connected is actually say connected with this, and that's also connected with this. Okay, I find now way to come here. So let's come through this. So it's a logic. You have to, if you have wisely placed this component, then you need not have to take all the way around. So in this case I think I have terribly failed in placing the components properly. This is another problem. See, from here I have to do this again. I have to run around my head to touch my nose. Too difficult to do that. 45-degree trace. Very bad connection. Is it? It's not getting connected. Okay, it's connected, so that line will be okay. So from here, okay, press escape, and better I rotate this component so that I can save a lot. So rotate counterclockwise once, again rotate counterclockwise once again. So see, now this is a much better. So if I rotate it like this, I can comfortably place the traces, maybe or may not be. Okay, so from here it's okay. So we usually do the parallel connections like this. So that's fine. And in my PCB now, this is uncomfortable. We'll do it first. That's completed, but now we have two more lines to be drawn, but I think we have a problem here. These are actually crossing. Is it? What to do? I could have rotated this component. So better I will no, it's okay, I can do that. This one, let me make this connection first. I can do like this. Do it parallel. Bad connection. Still okay for the time being. Okay, so this I can do this way. Okay, God's sake, I completed it. So now the design of a total PCB will look like this. There's a boundary, you have connectors here, here, and 3-pin connector here, and the 3 components distributed like this. Okay, so this completes the PCB design. So this snapshot of this you can actually include in your report. Now there is an interesting tool. I will just show you that. So in the view, we have a 3D viewer. So this will give you a 3-dimensional view of your actual board. So you can zoom in to see your 555 IC here, your resistor here, your capacitor. This is one connector, jumbo connector here. This is for VCC. This connector is for your ground, and these are actually the 3-pin connectors which you need for connecting this device with the tank connections, to make those tank connections. Okay, now we don't see any traces here, signal traces. We don't see any traces here because there's a single layer PCB, means all the traces are in the bottom layer, the components are in the top layer. Okay, just look into the bottom layer. Yes, we have those traces here in the bottom. Okay, so these are our 555 connections, 3-pin connector, and so on. So beautiful. So I think the dimension I choose for my PCB is much more than enough. Actually, I could have done this if I was talented. Then I could have done this in a smaller dimension, even like this. Okay, so I expect a good design from your side, well packed and well drawn. Means this a kind of beauty can be included in drawing these traces. See, this is very bad. You can see one. See, this point is very bad, but it looks beautiful in these 3 parallel connections. It looks beautiful. So this kind of beauty can be included in your traces, and compactness can be achieved in the component distribution. Okay, so you can include this figure also in your report. Okay, so this stops by this we